Okay, so obviously the heading there says proving similarity when the triangles are not given. So that's a bit of a spoiler. We are going to have to prove that triangles are similar here, right? And in the diagram that we have in the first question, there are actually only two triangles that we could work with. So we have the big triangle, which is triangle BDC. And then we have the smaller triangle, which is triangle EFC. Right, so we're going to have to prove that those two triangles are similar. Because when I have two triangles that are similar, then I can use my similarity statement, to set up my fractions, right? And once I have my fractions, I can cross multiply to get this statement. Yes? I can take the denominator of the one fraction over to the other side, denominator of the other fraction also over to the other side, and then I have my statement. Okay. But now, guys, if they don't tell you that you have to use similarity, you're going to have to recognize that first. Okay. So, guys, whenever you see a question like this, where you are asked, where they've given you a diagram with triangles in, sometimes there will be more than one triangle or more than two rather, and you need to identify them. But when it's a question like this where they've given you that statement, a product equal to a product, right? When I say product, I mean something multiplied by something else. So a side multiplied by a side is equal to a side multiplied by a side. Then you're going to have to use similarity. Or when we get to the next question, if it's a fraction equal to a fraction, right? Like the ones that we get when we do our frog faces, you are always first going to have to prove similarity. Okay, there's no other way to answer this question. Now, guys, if it wasn't an easy diagram like this, where we only had two triangles, do we understand why there are only two triangles here? This shape that I have here, is this a triangle? No, all right? So I can't say, oh, but I have this shape as well. That's not a triangle. Okay, so there are only two triangles. But now, guys, if there were more than two, you would have to identify which ones to work with. So what we're going to do, and this is a bit of a trial and error kind of situation. Sorry, my English is leaving me today. We're going to look at the letters that appear or are there in those first two sides that we have. So this is CE and CB. Which letters are there? I have a B and a C and an E. There are two C's, right? But that's fine. That doesn't matter. Now, guys, is BCE actually a triangle? BCE. No, that's not a triangle. Okay. What about the letters here? We have C and F and D, or C and D and F. It doesn't matter. Is that a triangle? No. C, D, F? No, that's a straight line. Okay, so that's not going to work. Then what we're going to do is we're going to look at, what about, let me use pink, across my equation. Let's look at those ones. What letters are in those two pairs of sides that I have? CEF or CFE, it doesn't matter, the order is fine. Now, is CEF a triangle? Yeah. Yes. Okay, so guys, in order to get these two sides in my fractions, I'm going to have to work with triangle CEF. Because in triangle CEF, CE is a side of that triangle, right? There we have CE. And CF is also a side of that triangle. So we need to work with a triangle so that when I do my fractions, CE and CF is in that triangle. Okay, but a quick way of checking is just kind of check across your equation. You'll see when we do the next one as well. Now let's quickly find the other triangle. I'm now going to look at the other two sides that are left, right? I already have a triangle that has CE and CF. Now I need to find a triangle that has CB and CD. So a quick way of doing that is just to check which letters do I have there. I have C, B, and D. And is that a triangle? C, B, and D? Yes, that is the big triangle. Okay, so if I work with triangle CBD, am I going to be able to put CB in my fractions? There we have CB, right? That's the whole side there. And the other side was CD. Yes, CD is in that triangle. Okay. We'll do more examples and then hopefully, you'll be able to do it on your own as well. Okay, so let's quickly do this now. So now, guys, we're going to say in triangle, and now you can decide what order you want to put your triangles in. Triangle CBD and triangle CEF. Now guys, the first mark for this question is going to be for identifying the triangles. So even there already, even if you don't know how to prove that they're similar, you can get a mark. Just for finding the two triangles that have these four sides in them. Okay, that will be your first mark for identifying the triangles. Okay, now again, if you don't know how to prove these triangles similar, just quickly underneath here, I'm going to list the three angles. So we have CBD. That's my first triangle. So in this big triangle, I have angle C, I have angle B, and I have angle D. And again, guys, if you don't have to, if you can see how to prove these two triangles similar straight away, then you don't have to do this. I think it's useful if the triangles are not easy to prove similar. So then CEF is the other one. So in triangle CEF, what are my three angles? We have angle C, we have angle E2, and angle F1. Now guys, I can see immediately that angle C is common, right? So those two are going to be equal. That's going to be my first line. Let's write that down so long. Angle C is common. You don't need to write a reason for that. Okay, now we need to show either that B is equal to E2 or B is equal to F1. What do you guys think? B is equal to F1. Hey, they're both equal to 90 degrees. There we go. That information was given. So B is equal to F1. So number 2, B is equal to F1. And the reason for that is going to be given. Because they told us by putting those little blocks on the diagram, they told us that those two angles were equal. And then we know that the third pair of angles will automatically be equal. So for the third line, I'm going to write angle D is equal to E2. And the reason for that is going to be angle sum in triangle. Therefore, now we need to get our order correct as well, right? They didn't give us the similarity statement, so we need to match the order that we have here on both sides. So we're going to say triangle CBD is similar to triangle. Now guys, angle C in the first triangle was equal to angle C in the second one, right? That angle was common, so C must go first again. Then I wrote B next, but B is equal to angle F1. So F must go next. And then D was equal to E, so CFE. And the reason, angle, angle, angle. Okay, so now we have that those triangles are similar. Now we can write the fractions from there. So I'm going to say CB over CF is equal to... Now guys, if I just do my frog faces for the next two, it's going to be BD and FE. But are those in what I need to prove? BD and FE, no. So we can leave that out. You can write it in if you want to, but because I can see that I don't have BD or EF in my prove that statement, I'm going to leave out that middle one. So then we have CD over CE. The reason for that, similar triangles. And now all we need to do is we need to cross multiply, right? Because I need to get CE times CB. Guys, I have CB at the top there. I'm going to multiply the CE at the bottom of my second fraction onto the other side. and then I'm going to do the same with the CF in the first fraction. So we're going to end up with CB times CE equal to CD times CF. Or if you want to, you can write them in the order that they gave in the prove that. But guys, we all know that 2 times 3 is the same as 3 times 2, right? So when you're multiplying, the order doesn't matter. So you can write it like this or like that. It's fine. It means the same thing. Okay, so a similarity question, you have to prove similarity, do your fractions, and then cross multiply. The only new thing now was identifying the triangles.